Okay, we're going to wrap up chapter 10 here with inequalities, right, and graphing their solutions. So here's a couple of examples. If we had x is greater than -5, right, we would draw an open circle to show that it's not greater than or equal to, and then the way this is pointing, the way your inequality is pointing, is the direction we're going to draw our arrow. Okay, now with that being said, that is always assuming that our variable is on the left-hand side. So when we're solving inequalities, we always want our variable over here. We've talked about before how if you've got an equal sign, really you can put your variable on either side. Although we mainly move it to the left just for this reason. When we have an inequality, I do not want my number over here. If it starts out like that and I switch it around, make sure if the little side is pointing to the x, I keep the little side pointing to the x and the big side to the 3. Only when your variable is on the left does it tell you the way to point your arrow. Okay, and once again, if it's just a less than or a greater than, you use an open circle on the number. If it has an equal, you use a closed circle. Okay, we can also have the x in between two numbers, right? So you don't have an arrow at all. These things will always point the little side to the left, big side to the right. If you have a compound inequality, this is a compound inequality. And this says it's read -3 is less than or equal to x and x is less than 2. You could also just say x is in between -3 and 2, including -3. Right? So notice when we had the equal part, we filled in the dot. This doesn't have the equal part, so it's got an open circle. And then you draw the line in between the two numbers. Okay, so here we go. Solve this inequality and graph the solution set. If it's an inequality, I always want my variables on the left. There's not any fractions or parentheses, so my first step is to put all of my variables on that left-hand side. So there's not any over here. So we'd have 5 minus 5x less than or equal to 8. Okay? Undo whatever's being added or subtracted to your variable. So -5x less than or equal to 5. Divide by whatever's being multiplied to it. So it's just like solving an equation, except I want my variables on the left definitely. And if you have to multiply through an inequality sign, it's going to change the sign of this number and this number. If I divide by a negative, it's going to change this to a positive and this to a negative. So I also have to change the sign of the inequality. Don't forget that. Only when you multiply or divide through an inequality with a negative, right? Not when I subtracted, not when I had a minus, not if I just needed to multiply, only when I multiply or divide by a negative. So I would change that to a greater than or equal to -1. Okay, because it's got the equal part, I'm going to put a closed circle, and I'm going to draw an arrow this direction. Okay. There's only one step here to get that y by itself. I'm just going to divide by 6. Since it's not negative, do not change the sign of that inequality. Okay, now it doesn't have the equal part, so I'm going to put an open circle on the 2. And then I'm going to draw an arrow this direction. Simple as that. Simple, simple. Oh, maybe not so simple. Still simple, just a little longer. All right, get rid of parentheses first. So I'm going to distribute this negative 2. So we have negative 2z minus 6 minus 5z less than or equal to, distribute this 4 to get rid of those parentheses, 4z minus 4 plus 9. Simplify each side. It's the same steps as solving an equation. Okay, so I have negative 7z minus 6 less than or equal to. Okay, here I can combine those constants, 4z plus 5. Put all your variables on the same side, and that needs to be the left if it's an inequality. Okay, so I have negative 11z minus 6 less than or equal to 5. Undo whatever's being added or subtracted to the variable. Okay, so we have negative 11z less than or equal to 11, and undo whatever's being multiplied by the variable. But remember, if you multiply or divide by a negative, you got to change the sign. So we would really have z is greater than or equal to negative 1. All right, open circle or closed circle? The equal part tells me to make it a closed circle, and the arrow's pointing to the right, so that's where I'm going to draw my arrow. Okay, fractions, but it's okay as long as we have an equal sign, remember, or some kind of equality relationship. I can get rid of fractions. I just need the common denominator, which between these two is 9. So I'm going to multiply everything by 9, not inside parentheses, not inside parentheses, right? Okay, now here 9 divided by 9 cancels out, so it just leaves the 7 times y minus 5. Okay, here 9 divided by 3 leaves a 3. So I have 4 times 3, 12 times y plus 5. Okay, now get rid of parentheses. So 7y minus 35 less than or equal to 12y plus 60. Put all your variables on the same side, and if it's an inequality, make it the left side. So we have negative 5y minus 35 less than or equal to 60. Okay, undo what's being added to that variable. So negative 5y less than or equal to 95, and undo what's being multiplied to the variable. Now, be careful, divided by a negative, so the direction of that inequality is going to change. And the sign will be changed to a negative also. So let's see, what is that, 19? Okay, now, this time will be kind of like on the test. If you have to draw your own number line, put the number you're interested in, and at least one number on either side. You don't have to draw a number line that has a 0 all the way down to negative 19, right? Or if your answer is a fraction, just put the fraction on there and then one number on either side of it. That'll be sufficient. So to the left of negative 19 is negative 20, and to the right is negative 18, and that'll be fine. Okay, I need a closed circle on the negative 19, and I need my arrow to go towards the right. There we are. Okay, so if we have an application problem, aka word problem, right, your favorite, then here's a few terms we might remember, right? If we say is greater than or is less than, that's obvious, right? That's a greater than and a less than sign. But we could also use terms like is at least or is at most, okay? Is at least, a lot of times people take that to mean, oh, let's do it less than because it's least. But no, we want this to be at least 6. So we want it to be 6 or more, right? At least 6, 6 or more. At most 8. 8 is the most it can be, so it has to be less than or equal to 8. For example, if Brent has test grades of 86, 88, and 78 on his first 3 tests in geometry, he wants an average of at least 80, right? So he wants it to be 80 or more. After his 4th test, what are the possible scores he can make? Well, first we got to figure out how to do an average. And an average means add them all up. And he's going to have another test, but we don't know what it is. And divide by how many there are. 1, 2, 3, 4. That's what his average is, right? You add up all your test scores and you divide by how many there are. And that gives you your test average. Now, he wants this to be at least 80. So he wants this to be more than or equal to 80, at least 80. So that's a greater than sign. Okay, I got a fraction. First thing I'm going to do is get rid of that fraction. So I'm going to multiply. Remember, this is parentheses. A fraction bar is as if there are invisible parentheses around the numerator and denominator. So don't multiply inside parentheses, but multiply everything by 4, but not inside parentheses. That means that can cancel. So we have 86 plus 88 plus 78 plus x has to be greater than or equal to 320. Do any math you can do. So I can just add all these together. Let's go over here and see what we have. 86, 88, 78, 16, 22, 10, 18, 25. So 252 plus x has to be greater than or equal to 320. Okay, now let's get that x all by itself. So x has to be greater than or equal to 68. Okay, so what are the possible scores he can make? Anything greater than or equal to 68. And he'll have an average at least 80. Okay, we will see you next time.